Let's look at geoprocessing in Model Builder. There are many types of models that we can create using cartographic modeling or map algebra. And these are just some examples of classes of models: suitability models, which include what-if models, cost-distance models, basic distance models, surface models, cost-distance surface models, hydrologic models, terrain models, etc. So there's all kinds of different types of models that can be built for specific purposes. And we'll look at a few of them here. The fundamental thing that you must understand about undertaking analysis with multiple raster layers is the importance of setting the geoprocessing environment. So to undertake modeling, we first have to set our environment. So that's the first thing up here, setting the environment. Then we conceptualize our process, and that can be done through creating Python statements or creating a tool, a toolbox, a model, and then eventually running the model or running a Python script. So notice the first step here is environments, setting the environments. And what does that mean? Well, environments control things such as the processing extent, so that anytime a tool or function is used, the output of that tool or function will honor or be within a certain extent, an extent being a x, y coordinate that, let's say, represents the left side and top of a region, and then an xy coordinate that represents the bottom and right side of the region. Other environment settings include things like the cell size, snap raster, and that's fundamentally important, and we'll talk about that in a couple of minutes. But these are things that are called environment settings. And there's a hierarchy to environment settings, and that's shown here on the right. So application settings are settings that you set in the environments when you do it visually through the Analysis tab, Environments. And those are called application settings, and they will apply to everything that you do in ArcGIS Pro, in the toolbox, or in the Python window, or anywhere else within ArcGIS Pro. It will use those application settings unless they are overridden. So for example, specific tools, you can override the global or application environment settings. So for example, you might set in your application settings, in the environments, an output cell size to be default of 10 meters. But then in a tool that you're using, you might want to override that because you need to create a raster that's 5 meters in size in terms of its cell size. And you could also, within a model that you build, have settings which apply to the model processes and outputs, and those will override the application settings. So they may, to ensure that your model works as you intended it every time, you may want to set environments within the model. Likewise, a process, a tuple within a model, could then have its own environment settings. Let's say it's a particular tool that's being used in the input tool output form. Then you might have the tool and its environment settings modified, and that will override the model settings and of course override the application settings. And these can be passed down to scripts. So model process settings could be a script tool, and they will pass down the environment there. And in a script, you can also have environment settings just all by themselves that override everything above. So it's important to understand that, to know, for example, why something frequently happens is that you do some processing with raster layers and nothing comes out, but you don't get an error. And you keep doing it over and over again, and nothing comes out, and you don't get an error. And it's often because you have set an extent in the application environment, and you're now working in a new coordinate system somewhere else in a different map, and you didn't go back and change that particular environment setting. So before undertaking any analyses, the key raster environment settings are the following: workspace, output coordinate system, processing extent, snap raster, cell size, and analysis mask. And the majority of the time, these will be set to one of your layers that you're working with. So for example, let's say we're using a layer called elevation, and that's going to be the layer that controls the size of the outputs, the cell size of the outputs, the extent of the outputs, the coordinate system of the outputs, etc. So in the environments dialog, we would go down to things like extent and say use elevation. That way every raster that is processed within ArcGIS Pro will have an extent that matches elevation as a DEM model, for example. The workspaces, you should generally be using the project-based workspace for your specific project that you have open in ArcGIS Pro. And they will default to those right there. But you can change them if you want to. We can set the output coordinate system, and that would be again the same as the layer elevation. If that's our control layer, for example, we'll call it a control layer that will control the coordinate system range or extent of the output and the coordinate system of the output, etc. Then we have to set cell size, and we put the same as elevation. The cell size projection method matters only if you're changing coordinate systems or projecting a raster to a new coordinate system and undertaking geometric transformation of that raster through that process. But generally, you want to have preserved resolution there. But it won't be used in any type of analysis with rasters that you're going to be doing in this class, because as a rule, before you undertake any analysis with multiple rasters, you will have controlled for the cell size and the cell size already. So you have to make sure that you have the same cell size for all your rasters and that they all have the same coordinate system as well. Here we also set a mask, and that can be any layer, raster or vector. So in this case, I say mask elevation. It won't be used necessarily because the extent of output is already elevation. And then a snap raster, elevation. The snap raster is very important because it determines how the cells will line up from the input layer to the output layer in a model process or in a statement in Python. We want to ensure that the cells coming out line up with the cells that are going into any process. And so we set that to one of our rasters. Now, in terms of cell size, the general rule is that the accuracy of your analysis when you analyze data with different cell size is at most as accurate as your least accurate layer, spatially speaking. So spatially here, least accurate means the accuracy of position. So if you have a layer that is 10 square meter cell size and another layer which is 5 square meter cell size in the same analysis, the accuracy of your analysis will be 10 square meters, or cell size as the output would be 10 square meters. because you can't get more information out of a 10 square meter. We don't know anything about, remember, sub-pixel variation. So we can't add more data to sub-pixels in order to match up and say, okay, let's just make 5 square meter cells out of our 10 square meter so we can do an analysis of 5 square meters. Because we're actually just duplicating the data that was in the 10 square meter cells. So keep that in mind, so that if by chance you do have a bunch of raster layers and some of them have different cell sizes, then you can choose, for example, maximum of inputs as the cell size in environments. But this again is something we should never encounter, because before we start any analysis, we should always resample our layers to a common cell size, that usually being the largest cell size in the set. So we can also set all those environment settings in the Python window as well. So if we don't want to modify our global environment when we're doing some analysis in Python, and the analysis that we're doing in Python has raster layers that aren't in the same coordinate system or anything as the map we're looking at, well, we can override the global environment settings in the Python window. So we import spatial analyst functions, the env class, as you saw in the demonstration video. And we can even save the original environment settings if we want to do something with them later on, like restore them back to what they are in the application level. So I can say env original equals env. That just makes a copy of the environment settings. Then I take my key raster or my control raster elevation, and I set the output coordinate system to that spatial reference. Snap raster, again, to that raster elevation. The extent, same thing, to that raster variable, which is a reference to the elevation layer. And the cell size, same thing again. And so once I set all of these in the Python window, then they stay set like this in the Python window until such time as I close and reopen ArcMap. So that's a very important thing to remember, because another common issue with doing analysis is that many people will not close and reopen ArcMap before they do analysis with a different set of raster layers that may be in a different coordinate system and different location on the Earth's surface. And so they do analysis and nothing is output. Again, no error comes, but nothing is output. And that's because they didn't reset the environment settings in the Python window to match one of the control rasters in their new location. And so you may have to set this multiple times in the same session if you're working with rasters that you're analyzing that are in different locations on the Earth's surface.